All right, let's continue with a couple more things that we need to know for our review and for our test. Suppose I'm going in this direction, so my velocity is in the positive direction, and my acceleration is the same sign in the same direction as velocity. So my velocity is positive and my acceleration is positive. In that case, I'm speeding up. Okay, that's how I speed up. Suppose I'm going the opposite direction, like this, so my velocity is in the negative direction, and my acceleration is in the negative direction. So my velocity is negative and my acceleration is negative. In that case, I'm still speeding up, but I'm speeding up to the left as opposed to speeding up to the right. Suppose I have a velocity to the right and an acceleration working against it to the left. Well, in this case, the velocity is positive because this direction I'm saying is positive, okay? And in this case, the acceleration is going the wrong way, so acceleration is negative. In this case, I'm going to slow down. All right, that's a slow down. And if the velocity is going in the negative direction and the acceleration is positive, so velocity is negative and acceleration is positive, I'm going to slow down. So you need to remember that in order to speed up, the velocity and the acceleration have to be in the same direction. Whether they're both negative or both positive, you'll speed up. If the signs are different for velocity and acceleration, you're going to be slowing down. All right? So with that, let's do a couple of problems so that you can feel comfortable with these things and feel great for the test. All right? So it's just some simple Chapter 2 type of problems. Let's say, for example, I'm in a car and I'm moving at an initial velocity of 5 meters per second, and I increase my speed to a final velocity of 20 meters per second, and I tell you I do that in 10 seconds. So I do that in 10 seconds. I'm going to ask you, what's the acceleration? All right, so you go to your motion equations, and the very first one, v final is v initial plus acceleration times time. So I'm told the final, so I get 20. The initial, I'm told, is 5. The acceleration, I don't know. The time is going to be 10 seconds, and I just solved this simple equation. So I subtract 5 from both sides, leaving me 15 here, equals 10 times acceleration. So acceleration is going to be 15 divided by 10, which is 1.5 meters per second squared. Students, do not forget your units on the test. That's very, very important to keep those units and to know what these SI units. This is the SI unit for acceleration. So in this case, I gave you the initial, the final, I gave you time. I could give you the initial, final, and acceleration and ask you to find time. You'd use the same type of setup here, the same type of formula. All right, so you're going to have 4 unknowns here. They give you 3 of the 4. You could find the 4th with this type of equation. And that's pretty simple, pretty straightforward. Suppose, for example, I tell you I have a car that's going down a highway, and a car is going to go from an initial speed or initial velocity of 10 meters per second to some final velocity of 50 meters per second. And I'm going to tell you, instead of having the car do that type of velocity change in a certain time period, I'm going to tell you that it's going to take 100 meters to do this. So if you can picture what's going on here, you have some road and you have a car on the road. I'm just going to draw a real quick one. And these are probably the worst drawings I'm ever doing because this pen is awful. So over here, the car is going 10 meters per second. Over here, the car is going 50 meters per second. Now what I'm going to tell you is that from this point to this point is 100 meters. All right? So the position of the car changes from here, which we can say this is where we're starting, or this is what we're talking about at this point where we're initially cruising along at 10 meters per second, and all of a sudden he's going to step on the gas and accelerate. So from this position right here, he's going to accelerate, and the speed's going to start to slowly start to increase until right over here, 100 meters from where we first looked at the speedometer, we're going to be at 50. So this is the final. And I want to know what kind of acceleration, let's do yellow. What kind of acceleration was necessary to have that car increase its velocity from 10 to 50 in 100 meters distance? Well, that 100 meters is the displacement. You got to realize and you got to understand that whenever we talk about length, we're talking about displacement. That's going to be the clue here, is this unit of meters. This is not a velocity. All right, I see a lot of times students are calling this velocity, getting all confused, plugging in velocities where they're not supposed to be. This is going to be measured in meters. This is a length. This is a distance. So remember this formula. Delta x is equal to VIT plus 1/2 AT squared. Well, we have delta x and we have A. No, we don't have A. We don't have A and we don't have T. So can I use this equation? Well, I got VI, that's 10, but that's not going to do me much good. So what do? Well, we don't panic. We don't say, gee, I don't know, this equation's not going to work. Find another equation. How about this equation? V final squared is V initial squared. And again, you'll have all these equations, plus 2 times the acceleration times your delta x or delta y. It depends. You know, you could use delta y if you're talking about displacements going down. But in this case, we're on a road, so delta x is good. Now we got some things we can plug in here, because the final velocity squared, well, that's V final. That's 50. So we can put 50 squared. What's my initial? That's 10. So let's put 10 squared plus 2. Do we know the acceleration? No. We need to find that out. Do we know the displacement? Yes, it's 100 meters. So put 100 there. All right, so now we could solve this. This you're going to square, you're going to subtract 10 squared, which is 100, and then you're going to 2 times 100 is 200, so you divide the whole thing by 200 to find the acceleration. Your acceleration, whatever that turns out to be, is going to be meters per second squared. This is important to remember. The units, put the units correctly on where they belong. All right, so let's try another problem. All right, let's try a problem that everyone was having a hard time with at the beginning of the year. One of these type of problems, something falling or being dropped from a building, and we call this vertical motion. Sometimes we call this free fall. So you have a guy standing up at the roof, and he's got a little ball, and he's standing up here, and we know that he's going to drop the ball, and the ball is going to fall down like this. And let's say, for example, I want to know if the ball hits the ground in, let's say, 10 seconds. It's going to take 10 seconds for the ball to hit the ground, and I want to know how high is the building, or how tall is this building that he's standing on. Well, the ball is dropped. All right. If it's dropped, what can you tell me about the initial velocity of the ball? Well, if it's dropped, the initial velocity's got to be 0, because at the start he's holding it, the ball is still. It's not moving. Then he drops it, and then it's going to pick up speed as it heads downward till the bottom, till it reaches the bottom over here. So I already know one piece. By the word dropped, I know that the initial velocity has to be 0. I've got time. And I have the acceleration too, because it's falling under the free influence of gravity. And whenever that happens, the acceleration is 9.8 meters per second squared, downward or negative. Okay? Because downward is going to be considered negative. So I want to know how tall is the building. So how am I going to do that? Well, got a couple of equations, right? Not a million of them. There's only like 3 or 4 equations. So let's think of what this means. Tall, how high, from here to here. that sounds like it's going to be a length, right? That sounds like I want something in meters. So I don't want velocities, I want displacement. So I could say delta y is VIT plus 1/2 AT squared. I know my initial velocity is 0, so this term drops out. And my delta y, in other words, how far it's going to fall down, is going to be 1/2 of negative 9.8 times time squared. And the time is 10 seconds, so this is going to be, well, 1/2 of 9.8 is negative 4.9, and that's going to be 10 squared. So my delta y is going to be 10 squared is 100, so it's going to be 490 meters, negative 490 meters. This negative sign simply means that this change in position is downward. So if you're at the top of a building, you're going to fall 490 meters, which means your building has to be 490 meters tall. Okay? That's kind of a problem that we did on one of the tests. And any of these free fall type of drop problems, you can do the same thing, especially if they're being dropped. You know the initial velocity is 0. And let's see if I can get one other one really quick in here before I run out of time. All right. So another building problem, think real quick. You have something here, again, a guy standing up here, he's going to drop a ball, so V initial is going to be 0. Ball is going to fall, and I'm going to tell you that, what do we want to find? We want to find, in this case, the final velocity, V final. We don't know what the final velocity is when the ball hits, but I'll tell you the building is 100 meters tall. And that's all I'm going to tell you. So can we solve this? Can we find the final velocity if you know it's 100 meters in the air and you're dropping the ball? Well, we can. V final squared is V initial squared plus 2 times the acceleration times the change in position. That's another one of our equations. Final velocity, we don't know what it is, but we know the initial velocity is 0. So 0 squared is still going to give us 0. 2, what's our acceleration? Negative 9.8. And what's our change in y? Well, we're falling or dropping 100 meters because that's how tall the building is. So we're dropping 100 meters. So we just have to solve for the final velocity then. This times this times this. So it's going to be 2 times 98 then. And the final velocity will be the square root of 2 times 98. And that's going to be in meters per second. Okay, so I hope this review helped, and we'll see you real soon.